With our spaceship flying controls and our weapons firing mode created and complete, in this video we'll create our player HUD and begin work on our game manager, which will be responsible for our game's points, enemies, player spawn, as well as controlling the different states of our game. In the link in the description, you'll find the link to freely download the assets and scripts or macro we created in this video. Feel free to download them and follow along, dissect the macro, or to simply use the completed effect in your game or project. Let's begin by creating our upgraded ship. To do this, we have to first set the tag of our spaceship game object to player, then duplicate our game object. Once duplicated, we'll make a prefab of the original, then remove it from our scene. Using the newly duplicated game object in our scene, let's now replace our sprite with the upgraded version. We want the upgraded ship to be able to fire at least 2 lasers at once, so let's duplicate our laser spawn point and place them on the left and right side of our ship. Keep in mind, due to the way we set up the ship's flow machine, we can have as many or as few laser firing positions as we like and don't have to change or modify our ship's graph. With that complete, let's now rename our game object, turn it into a prefab, and then remove it from our scene. Next, let's create an empty game object, which we'll call Astor Galaxy Game Manager SM. Let's then add a state machine component to our game object and create and save a macro, which we'll call Astor Galaxy Game Manager macro. We'll start by creating 2 empty game objects on our canvas. We'll call the first game object Game HUD and the second game object Pause Menu. And we'll also want to make sure that their anchor points are set to the edges of our canvas. Let's begin our game manager graph by creating a few scene graph variables. We'll start with creating 2 variables, one for each of the 2 new canvas game objects we just created, which are Pause Menu object and Game HUD object. We'll next create a variable for both our basic and upgraded ship prefab. Lastly, we'll create a boolean, which we'll name isShipUpgraded, and an integer, which we'll call player score. And let's grab the corresponding game objects or prefabs from either our scene or folder and place them in our new variable values. Let's also create a scene graph variable, which we'll call main menu manager object, and place our main menu SM as its value. Let's go into our start state, and in our start state we simply want to create 3 set active game object nodes, and we're going to use those to ensure our main menu manager object is active and our game HUD and pause menu are disabled. Let's now leave our start state and create a super state, which we'll call Astro Galaxy Game, and let's make a transition from our start state to our Astro Galaxy Game super state. Within this transition, we simply want to have a boolean check, and the boolean we're checking is a scene graph boolean we need to create, which we'll call CanPlayGame. Let's next go into our main menu state machine, and in our play game state, after deactivating our scene graph object variable, we want to set the value of our CanPlayGame boolean to true. Let's now go into the start state of our Astro Galaxy Game super state. We want to begin by first spawning our basic spaceship into our game. So let's first rename our game object to AG Game. Let's next create an empty game object to be a child of our AG Game object. We'll reset its transform to 0 and rename it to spawn points. We'll next create a 3D cube or an empty game object, which we'll use to set the player spawn point. And let's also rename this game object to player spawn point. With that complete, within our game manager graph, we want to create an object graph variable, which we'll use to set and store our player spawn point transform. We'll set the variable's type to be a transform, and we'll use the transform from our player spawn point game object as its value. For this graph, we'll start by first setting our game HUD to active. Let's then set our isAlternateFire boolean as well as our isShipUpgraded boolean to false. And lastly, let's instantiate our basic ship prefab and use the position from the transform of our player's spawn point game object. Before we continue, let's test the new functionality we've created so far. We can see within our start graph that it set our main menu game object to true. Additionally, it also deactivated our game HUD and our pause menu, as well as our AG game object. We can see when we started our game, we were taken into our Astro Galaxy game super state, which spawned our ship in our player spawn location. With everything seemingly working correctly, let's go back into our graph. Within our super state, let's create two new flow states. We'll call the first one paused, and our other state is playing. Let's go back into our start state, and at the end of our graph, we'll create a custom event trigger, which we'll call can play. Let's now make a transition from our start to our playing state, and within our transition, we'll use the custom event we just created to trigger our transition into the next state. Let's now make a transition from our playing state to our pause state, as well as a transition from our pause state to our playing state. To trigger our transitions both to and from our pause, we're simply going to use a keyboard input event. However, before transitioning to our pause state, we wanted to pause all the movement and action in the game. So before triggering our transition, we want to use a set timescale node, and we want our value to be 0. And let's now copy our nodes, and we're going to paste them in our transition from the pause state to the play state. And we're going to set the value of our timescale to 1, since 1 is our default timescale value. And before we create our pause menu, let's test our pausing functionality. We could see once we hit our key input that all the movement and animation in our game paused. Before we continue creating our graph, let's add the UI elements for both our game HUD and our game pause menu. If we look in our textures UI folder, we'll see that we not only have menu elements, but we also have elements for HUDs and maps. So let's create a UI image, which will be a child of our game HUD canvas game object, and let's scale and place it to fit our scene. Something to note, if some of our sprites are showing on top of our canvas elements, if we click on our canvas game object and look in our canvas component, we can see that it also has a sorting order and layer value. So in order to make sure that our canvas elements appear on top of our game sprites, let's set our order and layer value to 50, which is much higher than any of the sprites that are in our scene or that we've made prefabs of. Let's next add two UI text elements to the game HUD, and we'll use one of the elements to display our player's score, and we'll use the other to display the amount of alternative fire charges that the player has left. Something to note, oftentimes when creating HUDs in UI, we find that temporarily bringing in scene elements or characters is a great way of getting a better sense of how the HUD and UI elements will appear to our player. For example, by adding our ship prefab to our scene, due to our sprite size, we can see that our footer HUD element takes up an unnecessary amount of screen space. In cases such as this, we found that using a UI element based HUD can give the player far more screen real estate. With our game HUD now complete, let's create the pause menu UI before going back to our graph. Like the HUD and main menu UI, we have a variety of different types of pause menus we can create using our UI elements and sprites. With our game HUD and pause menu UI canvas complete, let's now go back into our game manager graph. Let's begin by creating three object graph variables. One for our player's score UI text component, one for our alternate fire charge number text component, and one for our ship upgraded image game object. And let's also set the variable types and use the corresponding game object in our scene for their values. Let's next create our variables we'll need for our pause menu. For our pause menu, we'll create two object graph variables, one for our return UI button and the other for our exit game button. With our variables created and assigned, let's now go to the start state of our AG game super state. In our start state, we want to create a group of nodes that will set our player score display text to our player score variable value. And we also want to set our alternate fire charges display text to the alternate fire charges variable value. Let's begin by first setting our player score display text. To do that, we'll use the value from our player score scene variable. Since our value is an integer, we'll need to use an integer to string node. We'll use the output of our integer to string node in a text set text node and set our player score display text variable as its input text value. To start these nodes, let's use a custom event, and we'll call our custom event set score. Since we'll need to use the same process for alternate charge display text, let's select and duplicate our node group. Let's change the name of our custom event to set alternate charge. And let's create a custom event trigger after our player score display set text node, and this custom event trigger will trigger our set alternate charges node group. Let's also move our can play custom event trigger to trigger after our alternate charges display text set text node. So instead of triggering our can play custom event trigger after our game object instantiate node, we'll simply trigger our set score custom event. Let's also change our input text variable to alternate charge display text and our integer to string input variable to our alternate charges scene variable. And let's also create another game object set active node, and we'll place this node after our first game object set active node. And for our input target, we'll use our upgraded display object. Since our player doesn't start the game with their upgraded ship, we want that to be set to inactive. With that complete, let's go into our pause state. In our pause state, we simply want to deactivate the HUD and activate our pause menu game object. Let's also create another scene graph boolean variable, which we'll call cannot fire. And instead of our pause state, we want to set this variable within our transitions to and from our pause state. Despite the fact that our time scale is 0, by pressing our fire button, the player can still instantiate laser beams and laser blasts. So we're creating and setting this boolean to prevent that. So after our set time scale node, we want to create a set variable node to set our player cannot fire to true. And in our transition from our pause state to our playing state, we'll simply set that variable back to false. And we'll also need to reactivate our game HUD before transitioning back to our playing state. Lastly, let's create an on button click event so we can use our return button in our pause menu to unpause the game. We also need to be sure that we deactivate our pause menu game object as well. With the basis of our game manager, in-game HUD, and pause menu complete, in our next lesson, we'll create our upgrade functionality, as well as the ability to add and remove charges and points from our display.
Don't forget to subscribe and hit that notification bell to be the first to see this and many other tutorials, game development tips, and free game asset giveaways.